Hello, so here I have some functions and how we can find asymptotes from them. Horizontal, vertical, and oblique asymptotes. So our first function is ax plus b over cx plus d. So to find the horizontal asymptote, you're going to compare the coefficients and divide them. So let's say for this example here. So the coefficient of x on the top, well, that's 0 because there's no x on the numerator. Coefficient of x on the bottom, for x on the bottom is 1x. So the horizontal asymptote is going to be 0 over 1, which is 0. So horizontal asymptote is going to be at, well, horizontal is like this, so it's going to be at y equals 0. Okay, and now how about for the vertical? For the vertical asymptote, what you do, this applies for all types of functions, is you set the denominator to 0 and you solve. So for this example, 2x plus 2 equals 0, therefore x equals minus 2. So that would be x equals minus 2. There we go. Okay, the second function here. So 3 over 6 is a half. So 1/2 is going to be the horizontal asymptote. Then for the vertical asymptote, we set this to 0. We minus 2 on both sides, so that will be minus 2 over 6, which is minus 1 over 3. Minus 1 over 3. There we go. Now let's move on to the second function you could get, which is ax plus b over cx squared plus dx plus e. So you can see that the denominator has a squared value. And this means that the horizontal asymptote will be 0. And the vertical asymptote, you'll have to equate to 0 and solve once again. So for this example, the horizontal asymptote is y equals 0. Okay, so is this example right here, y equals 0. Okay, however, we have to solve the denominator to get to the vertical asymptote. So here, we know that the square root of 1 is plus or minus 1. So the asymptotes will occur at x equals minus 1 and x equals 1. A difference of squares, x plus 1, x minus 1. Okay, and here, x cubed minus 5, x cubed minus 5 equals 0. So 5 equals x cubed. So x will equal the cube root of 5. And I believe there's only one solution for that, which has to be, yep, okay. So what we do here is we simply, we just write down the vertical asymptote as cube root of 5. Okay, if you have a calculator, you can bring that down into decimal form if you want. So here we have this format where ax squared plus bx plus c is over dx plus e. And for here, the horizontal asymptote does not exist. It's going to be an oblique asymptote, meaning that it's not going to be like this, it's going to be tilted. So let's take this example. X squared plus x minus 2 over x plus 4. So you could use some synthetic division. I'm going to use long division. So what you're going to do is you're going to have to find the remainder of this. So x squared plus x minus 2. We're going to put x plus 4 here. We're just going to do division here. So our first term is going to be x, because x squared, and then plus 4x. We're going to subtract, so this is going to be 0, and then minus, that would be minus 3x. We're going to bring down the 2, minus 2. Okay, and now we're going to do minus 3. Minus 3, so this becomes minus 3x. They're going to cancel out with each other, because it's going to be subtracting. So that would be 0. Minus 3 times 4 is minus 12. That will become 10. So our remainder is 10. So this function is now this. F of x equals x minus 3 plus 10 over x plus 4. So this is a new way of formatting this. And actually, in asymptote, we know that while as x approaches infinity, we're going to get closer and closer to that asymptote, because I'll write down here, but the limit as x approaches infinity of 10 over x plus 4 is going to equal 0. So therefore the horizontal, or the oblique asymptote is going to be the linear equation x minus 3, y equals x minus 3. That is going to be the oblique asymptote. And then for the vertical asymptote, it's just going to be setting the denominator to 0. So x plus 4 equals 0. So x equals minus 4. So for this one, x is going to equal minus 4 for the vertical asymptote. And there we go. That's how you solve for asymptotes. Thank you.